So, exactly. So what you can see is this is kind of like an arbitrary unit that Madame Curie came up with to describe the activity of one specific isotope, radium-226, that she happened to use in her laboratory and that she studied for her life. So, good for her. So,
Good eye. Good job, Madam
well,
Curie.
yeah. Well, so, you know...
Which just sounds like a made-up tale, because who the hell does that?
Yeah, and you know that's why she named it a Curie, because she named it after herself, obviously.
Natural.
And she said that's what it is. So that's one Curie. So she's gonna say, so
I'd call
one
it
Curie of radium-226 weighs how much?
Not a lot.
We just talked about this.
Not a lot.
Weighs.
How much does it weigh in mass? How many grams is it?
It's 0.87.
One Curie of radium-226.
It's gonna weigh a gram.
A gram, exactly, because that's what she said. She said 1 gram of radium-226 is 3.7.
Which isn't a lot, so I was technically...
You're right. I'm just saying you guys are listening and we're actually just, okay.
Oh, Lord.
So by the definition that Madame Curie came up with and named after herself, 1 Curie of radium-226 is 1 gram. And that gives off exactly 3.7 times 10 to the 10th decays per second. So what about other elements, you know? What about cesium-137, for example? How much does 1 Curie of cesium-137 weigh? Well,
is it like 3.2? We have these numbers somewhere.
Well, that's the exposure rate.
well, really,
constant.
to be honest
That's
with you,
not
it's
how much
so
they weigh.
the weight is kind of irrelevant. The point I'm trying to drive home is that the actual weight would be equal to the amount that gives off 3.7 times 10 to the 10th decays per second. It doesn't. I'm not trying to drive home exactly what the weight is. What I'm saying is the weight is going to be different. It's not going to be 1 gram. 1 gram of cesium-137 is not going to be equal to 1 Curie. It's going to be equal to whatever gives off an activity of 3.7 times 10 to the 10th becquerels. Does that make sense?
Are we weighing this one?
You're confusing us with the weight of the we always the decay constant, the exposure rate constant's one thing, the half-life's one thing, the weight we never really discussed how much something weighs.
Well, that's
Well, the airlines are getting ready to.
well, when we say
I'm confused.
that's the point of what I'm trying to say is that all of these activities and exposures and everything we're talking about is based upon 1 gram of radium-226.
Right, okay.
So 1 gram of radium-226 is 3.7 times 10 to the 10th decays per second. That's what you're going to get from 1 gram.
Right.
So you're going to get 1 Curie. So if you're looking for cesium-137 now,
okay,
1 gram of cesium-137 is not necessarily going to give you 3.7 times 10 to the 10th.
Right.
But if I were to say if I were saying 1 millicurie of cesium, it's not going to be necessarily 1 gram.
Right.
So in my limited knowledge, then are you trying to get to the whole 8.25 divided by 3.67? Okay.
That's where I'm going.
Small little brain here, yes.
So,
okay.
Are you just taping him, or are you...
Yes, because I can hear this.
Yeah, but you don't have to hold it, really. You could set it down and just let it record his voice, because you're going to be watching 3 minutes of
This
the
is my
whiteboard.
video, just...
Okay. I'm watching the whiteboard. Nothing's happening on the board.
Okay.
So you could technically put it down.
This is my friend Sharon in class, annoying me.
Go ahead.
Okay. So we just talked about exposure rate constant. Now we're talking about moving on to, we talked about this earlier. What is exposure?
I'm ready.
So exposure is the ionizing capability of an element. So all ionizing radiation, as opposed to non-ionizing radiation, which would be something like visible light, for example, can ionizing radiation obviously ionizes air, meaning they kick off electrons from atoms, creating ions. Now some elements give off gamma rays, some radioisotopes give off betas.
Mm-hmm.
Some of them give off gamma rays with an energy of 21 keV, for example. That would be like palladium-103, I believe.
Mm-hmm.
Others give off energy of 662 keV, others of 1.25 MeV. So as you can see that radon gives off about approximately an average of 800 keV gammas. Now, the energy of a particular element, or the energy of the radiation that a particular element gives off, is related to how ionizing that element is. So some are more ionizing than others because they give off more energetic radiation than others. So how can we equate basically the ionizing power of one element to another? And that's where this idea of exposure rate constant comes into play. And it's basically you're trying to equate the ionizing capability of different elements based on that element's particular characteristics and the energy of that particle that it gives off. So like the energy of that gamma that it's giving off.
Okay.
So for example, say we have radium-222 in this case. We'll call this, radium-226. And we'll see the gamma constant for this.
There we are.
Actually,
New ones?
Oh yeah.
so we say the gamma constant for this is 8.25 Rankins. So those are the Rankins per hour from 1 millicurie per millicurie at 1 cm away, 1 cm
Okay.
squared. So in this particular case, this is our. Now I'm telling you, this is radium. It's 1 millicurie at 1 cm away. What would be our exposure rate?
Okay.
What would it be?
8.25.
8.25, exactly.
Right.
That's what this is telling you right here. Alternatively, we've said that 1 curie of radium, right, is equal to 1 gram,
Right.
right?
Mm-hmm.
Because it's based. The definition of curie is based upon its weight. So if I were to say 1 millicurie of radium-226 is equal to how much weight? 1
100.
milligram.
Oh, okay.
Right?
Okay.
Isn't that the same thing? So now I'm saying 1 millicurie is equal to 1 milligram. So here I have 8.25 Rankins per hour per millicurie at 1 cm. It's also the same thing as saying Rankins cm squared hours per milligram.
Okay.
So this is why for radium-226 specifically, the units can be millicuries or milligram, because by definition, they're the same, because it's based upon the weight. That's the whole idea.
Okay. And okay.
But that's only true for radium-226.
Okay.
Okay?
Yeah.
Everything else, all other gamma factors, or they're actually called exposure rate constants, or sometimes they're called gamma factors because this is a gamma sign. That's the symbol for gamma. So sometimes they call them gamma
Factors
factors as well. All other isotopes that have gamma factors will have these units with millicurie in the bottom, not mg, not milligram.
Mm-hmm.
Because that is based upon not necessarily how much that weighs, but how much of that activity of that particle, of that element, sorry. Make sense?
Yeah.
So, for me, could everyone calculate the exposure rate at 1 cm away from a 2 millicurie source of radium-226? What is the exposure rate?
Is it 1 cm away?
It's 1 cm away, but I've changed this from a 1 millicurie source to a 2 millicurie source.